Length of an arc. We know that the length of the circumference of a circle is given by C is equal to 2 pi r, where r is the radius. Suppose we only want an arc rather than the whole circumference. So in other words, we just want this part of the circle. So we have an angle in the middle here, and let's say that angle is theta. The fraction of a whole circle we are dealing with is theta out of 360. Remember, the whole circle goes around 360. This one just goes around theta. So as a fraction, that's theta over 360. So the length of the arc is this fraction of the circumference. In other words, the length of the arc is theta 3/60ths of the entire circumference, which is 2 pi r. So we want to find the following arc lengths. So we can see the radius here is 8 and the angle is 110. So my arc length would be 110 3/60ths of the entire circumference if this was a whole circle, which is given by 2 times pi times the radius. So we just need to calculate this. So let's just bring in our calculator, and I've got 110 divided by 360 and multiply that by 2 and by pi and by 8. And that gives me 44 over 9 pi, which is the exact length. And what we can do here is convert that into a decimal, and let's say that's approximately 15.4 centimeters. So the next one has an angle in the middle of 50, so that means we're looking at 50 360ths of the whole, multiplied by 2 by pi by 12. The 2 pi r, remember, is the circumference of an entire circle. And so we just need to calculate that. So let's bring in the calculator, and I could actually just go back and edit this one. So we want 50 on top here, and we go back along here, we've got 12 instead of 8, and that gives me 10 over 3 pi. Should put the units in. I don't think I did put the units in over here with the exact answer, and of course I should have done. And of course we could give that as an approximate value as well. So that's approximately 10.5 centimeters. And of course you could give this to any number of decimal places that you want.